Hello, Algebra 2 students. This is going to be a few of the even problems from your homework so you can see how it's done. First, I just want to make sure you've watched your videos and you learned what sine, cosine, and tangent are. Three you may not be familiar with yet are cosecant, secant, and cotangent. All the cosecant is the flip of the sine. So it's hypotenuse over opposite. The secant is the hypotenuse over the adjacent, and the cotangent is the adjacent over the opposite. An easy way to remember is that sine goes with cosecant. So S and C flip, C and S flip, and the two with tangents flip. So with this in mind, let's look at number 2. It's asking us to find the sine of R. Well, first of all, we're missing one. We're missing a spot. We're missing this side. We're missing the hypotenuse. So what method can we use to find the hypotenuse? Well, we can use the Pythagorean theorem. So we would have side squared plus side squared equals hypotenuse squared. So it would be 8 squared plus 15 squared equals the hypotenuse squared. So you have 64 plus 225 equals h squared. So this would be 289 equals h squared. For now, I'm just going to do square root of 289, only because somebody might walk in and I need to shut the video, so I need to finish it. So the sine of R would be opposite, which is, if you're standing inside this angle, looking across, that's the side opposite. The side adjacent is the one that's next to it. This would be the adjacent. It would be next to it, but it's not the hypotenuse. So it's the side next to it that's not the hypotenuse. So the sine is opposite over hypotenuse. The cosine would be the adjacent over the hypotenuse. I'm hoping I did the 289 right. So the cosecant is the hypotenuse over the opposite. So the cosecant would be 289 over, what's the opposite of S? It's not the same as the opposite of R. It's the side that's opposite of S. So it would be over 8. And the cotangent of S, see now we're looking at S, would be the adjacent, which would be 15, over the opposite, which would be 8. So that's how you find the missing parts of a triangle. This one, you're not going to do this kind of stuff too much later in life, but it's always good to know that there are 60 seconds in a minute and 60 minutes in a degree. This is all from Babylonia, which is why it's all in 60s. That's how we get our time, our 60 minutes and 60 seconds and things like that. So first we have to change this into a decimal form of just degrees to be able to punch it in our calculator. So 29 over 30, over 60 will give us our fraction of minutes. So we would say 29 divided by 60 is 0.483. So now we have 64 degrees, 50.483 minutes. So now we divide the minutes by 60. So let's divide that. Is 0.841. So now we have 64 degrees, 64.841 degrees. So we're looking for the sine of that. And if you remember, if you didn't have it last year, all you do to find the sine of an angle is make sure your mode is in degrees, because some calculators have been changed to radians. So just hit sine and then punch in 64.841 and you get 0.905 degrees. So, I mean, the sine is 0.905. Sorry about that. But that would be the sine of 64.841 degrees. All right, let's do number 4. It wants us to write the 3 basic trigonometric functions of, let's see, which angle do they want? Of each acute angle. Well, first of all, the acute angles are not the right angles. So they want the sine of G, the cosine of G, and the tangent of G. And then they want the sine of K, the cosine of K, and the tangent of K. And I hope this is all going to be on the board here. But once again, we use the Pythagorean theorem. So this is the hypotenuse. So you would do 36 squared plus 15 squared equals h squared. I'm going to do that on the calculator quickly. 36 squared plus 15 squared. And then I'm just going to get the square root and get a decimal approximation. Well, you don't have to. It comes out exactly 39. So the hypotenuse is 39. So the sine of G, remember we're at G. So opposite, shoot an arrow, is 36. So the opposite is 36. The hypotenuse is 39. Cosine of G, you have two sides that are adjacent. But one of them is the hypotenuse, so that's not the one we use. We only use the one that's adjacent that's not the hypotenuse. So you would have 15 over 39 because that's adjacent over hypotenuse. And then the tangent is opposite to G would be 36 over adjacent to G would be 15. Now we're going to go over to K. K now has a whole different set. Across is 15. So the sine of K is 15. Hypotenuse is still 39. The cosine of K is now 36. And the tangent is 15 over 36. Now I just want you to notice something that you're going to be using later on. The sine of G is the same as the cosine of K. So the sine of G is the same as the cosine of K. So if they're in the same triangle, the sine of one is going to be the cosine of the other, and the cosine is going to be the sine of the other. Just something to remember for the future.